Okay, we're moving on to lesson 5 out of the module 3, and we're gonna come back to a familiar subject, exponential growth. We remember from previous classes or lessons that exponential growth, or the chart of exponential growth, looks something like this. Okay, so it's a curved line that exponentially goes up. So when we talk about exponential growth, it means something that starts off really slow and then it picks up really fast, like growing the money into your account, usually your retirement fund, or something like that. Bacteria, remember we watched that video about the bacteria, that was exponential growth as well. So the outcome of this lesson is that we should be able to model with and solve problems involving exponential formulas. Before we look at the opening exercise, I just want to make sure that we remember a couple of things that we discussed in previous lessons, which was a while back. We talk about arithmetic, and geometric sequence. Okay, so when we talk about arithmetic, we are looking at something that can be added. So it involves addition. So it could be as simple as, for example, 3, 6, 9, 12, and so on. So to find out if it's arithmetic, then we take the second term and subtract the first term, and then we get 3. Then the third term, 9 minus 6, is also 3. So if the difference between the terms is the same, that means that that sequence is arithmetic. When we talk about the geometric sequence, we can have something like this: 3, 9, 27, 81. So if I were to find the difference between the last, the second and the first, it will be 9 minus 3 is 6, 27 minus 9 is 18, and so on. So you notice that the difference is not the same. But I realized that if I multiply 3 times 3, I get 9. So then 9 times 3, so you'll get 3 times 3 is 9, and then 9 times 3 is 27, and 27 times 3 is 81. So we found a pattern that we're multiplying the previous number by 3. So for geometric, the way we find the geometric sequence is by multiplication. Okay, so just make sure that you understand when we're talking about arithmetic, we're talking about addition, and geometric means multiplication. Okay, so let's look at the opening exercise. 2 equipment rental companies have different penalty policies for returning a piece of equipment late. On Company 1, they charge $5 day 1, then $10 day 3, so and so on, increasing by $5 each day the equipment is late. Okay, so if we were to fill out the chart, we will write 5, then 10, 15, 20, 25 on day 5. So I want you to keep going and fill this out. For Company 2, it's a bit more different, because the penalty for day 1 was 1 cent, so 1 cent. For day 2, I'm right here, is 2 cents. Day 3 is 4 cents. So notice that it doesn't go 1, 2, 3, 4. It goes 1, 2, and 4. On day 4, it jumps up to 8 cents. So we're doubling the amount each day it's late. In the previous one, we increased, so we added 5 each day. Okay, so there's a big difference between the two companies. So make sure you fill out both companies' chart all the way to day 15th. Okay, to the bottom. So let's read the bottom of the word problem here. Jim rented a digger from company 2 because he thought he had a better late return policy. The job he was doing with the digger took longer than he expected, but he did not concern himself. It did not concern him because the late penalty seemed so reasonable. When he returned the digger 15 days late, he was shocked by the penalty fee. What did he pay, and what would he have paid if he used company 1 instead? So I'll give you a few minutes to complete both tables. And for the question, I'm going to ask you, what would the penalty be on day 12 for both of them? So I need the two numbers, a penalty for the company 1 and a penalty for the company 2. And also, what would the penalty be for day 15? Okay, so the question is, question A, which company has a greater 15-a-day late charge? So if you actually calculated if you completed your table, you'll realize that company 2 charges on day 15. So this is day 15, $163.84, whereas the company 1 charges only $75. So which one has a greater charge? Will be company 2. So the answer is company 2. Going to question B, describe how the amount of late charge changes from any given day to the next successive day in both companies. So if we were to look back to our table, we realize that for company 1, okay, the change from any given day, so any day we pick out of the 15, to the next successive day, which is the following day, is an increase of $5. So plus 5. But if we look at company 2, we realize that the change from any given day to the next following day is an increase by a factor of 2. So we're multiplying times 2. So even if you take, let's say 32 cents times 2 is going to be 64 cents. So this is the big difference. So when we talk about the arithmetic and geometric sequence up at the top, we said arithmetic, sorry, has to do with addition. So this should be arithmetic or arithmetic, however you want to say it. And the second one, because we're dealing with multiplication, is going to be a geometric sequence. Okay. So the answer for B is company 1 increases by adding $5. So we're adding $5 each day from any given day to the next day to the next following day. For company 2, though, the increase is by a factor of 2. So we're using multiplication. So that's why I put the multiplication sign in parentheses to know that we're multiplying. And for the top one, it's going to be addition. So put the addition sign. So for question C, how much would the late charge have been after 20 days with company 1. For that, we need to find the formula for each sequence. So for company 1, the formula would be, how do you find the formula for company 1? We have to look at our table, and we realize that we're adding 5 each time. So the shortest way to do it is, what if we multiply the number of days times the penalty? So 5 times 1 is going to be 5. To find the easier way to for the formula is, we know that if we have a sequence of addition, that becomes multiplication. So if I have 1 times 5, it's going to equal 5. But we're going to use 5 as our first or initial day, so day 1. So we're gonna have the first function f of n. So we're gonna let n be our number of days. Okay. So every time we see day n, we know we're referring to the sequence, or the number of days in this case. So f of n will be 5 times n, because I realized that I can multiply 5, which is our initial penalty, and multiply by the number of days and find it for each day. So let's say you want to find the f of 10. F of 10 will be 5 times 10, which is 50, and 50 checks. Okay, so let's go on to the next one. Okay, it's a bit more complicated, but we're going to use f of n again, and we're going to start with our initial penalty, which is 0.01. So we know that each one of these is multiplied by 2. So I'm multiplying this times 2, and then we're going to raise it to n minus 1, because if we were if you remember from previous classes, we always use the day before to raise it to that power. It's going to be 0.01 times 2, and then raised to the first power. So I want to plug in another number for another number of days. So let's say the same thing we did over here. Let's do f of 10. So then what would be the penalty using the formula without looking at the table? So I'll have 0.01 multiplied by 2 and raised to, now instead of writing 10, I write 9 because I have n minus 1. You can use the calculator and find out that 2 to the 9th power is basically 512. So we're going to have 0.01 times 512, which is $5.12. And that's what I had up here. So going back to question D, these are the two formulas that we're going to use. So all we have to do is plug in f of 20, and I realized that 5 times 20 is 100. So $100 for company 1, and then for company 2 I also have f of 20, so that will be 0.1 times 2 raised to the 19th power. So if we raise 2 to the 19th power, we get 524,288, and multiply that times 0.1, we get 5,242.88. Okay, so we're skipping the next example, and we're going to go to example 2. And this you can do on your own. Okay, they already gave you the formulas, which is fn equals 2n, and then fn equals 2 to the nth power. So all we're doing is we plug in the value for n into the formula on both sides. So all we're doing is you plug in the values for n into f of n, and we say 2 times -2 is -4, and so on. And the same thing for the bottom one. So the y-axis is f of n, and the x-axis is n. So for the first equation, for every increase in 1 unit, the f of n goes up by 2.